My name is Dan Korsun. I'm studying physics here at MIT, and my research is into the effects of radiation damage on REBCO high-temperature superconductors. So REBCO stands for rare earth barium copper oxide, and it's a type of superconductor that we're looking at here at MIT to build the next generation of fusion devices. So nuclear fusion is kind of like making a star on Earth. It's replicating what the sun and other stars do to produce almost limitless amounts of clean, carbon-free energy. And so here at MIT, we're actually building a new device called Spark. And Spark will be the first fusion device to actually produce more power than it takes to run. And Spark will do this by actually using magnets for the first time made of this material called REBCO. And REBCO is a very, very special material. So it's a superconductor, which means it can carry incredibly high amounts of currents and under specialized conditions. So here we actually have like a traditional copper cable you would see in a traditional fusion device. And here we have a little piece of REBCO. And under certain conditions, this little piece of REBCO can actually carry the same amount of current as this big copper cable. And that is what enables us in Spark and in future such devices to actually produce such large amounts of power. And so what my research focuses on is emulating how the neutrons produced in fusion reactions will actually damage REBCO and impact its performance over time. And so very little is actually understood about how REBCO will be damaged by such neutrons. And my work is actually focused on applying reactor-relevant irradiation conditions like low temperatures and high fields to these REBCO samples to emulate and predict how such magnets will perform over time in fusion devices, which will impact the viability of these devices going forward.